Well, Rosemary, the big news here in America is that there was a balloon floating across the United States that we all watched slowly drift from one ocean to the other.
I can't figure out what on earth it was for, or what the cause was. And I agree, I would probably shoot it down too, just, so that you're sure. But
that's what I'm saying.
Yeah, super weird.
Right.
Super weird.
Yeah, it was a very strange week for that to happen. So next time there's a balloon, hopefully just send it south. It stops sending it to America because it's freaking out America at the moment. And speaking of freaking out, there's a lot happening in wind news this week. Every day is just a plethora of really cool stuff. This week we're going to talk about integrated photonic sensing, basic fiber optic sensing in wind turbine blades, and that's based on an article we saw in Power and Energy Solutions magazine. And then we take a deep look at Vestas announcing a method to recycle the epoxy resin in existing wind turbine blades. So breaking down the epoxy into virgin components so we could reuse to make more wind turbine blades. Really cool technology.
Yeah, and then we talk about another project that Vestas have invested in, the Modvian wooden wind turbine towers. And I talk a little bit about whether it's really more sustainable than steel will be in the future. And then on to wind catching, that it's a new kind of offshore wind turbine with like a grid array of small wind turbines. And I try the questionable tactic of hoping that they will hire me to help them with their development by criticizing them a lot. So let's see how that goes for me. And then we've got the wind farm of this week is the Budweiser Wind Farm at Thunder Ranch in Oklahoma.
And also, just to note, WeatherGuard Lightning Tech is going to be at American Clean Power, O&M, in Orlando, Florida, in the beginning of March. So if you're down in Orlando, stop and say hi. I'm Alan Hall, president of WeatherGuard Lightning Tech, and my good friend Joel Saxum is on an airplane this week, headed to a wind turbine site, and the soon-to-be guest host of Fully Charged Live in Australia, Rosemary Barnes, is here, and this is the Uptime Wind Energy Podcast. Well, Rosemary, I saw an article in Power and Energy Solutions magazine on PhotonFirst, which is a company based in the Netherlands, and they do fiber optic sensing, but with a twist to it. And I thought of you first when I saw this article, because we know anything you put into a blade really can't be conductive for lightning reasons. It'll blow up the blade. So the option is to put fiber optic into the blade and to do sensing that way, because fiber optic is made out of plastic and it won't attract any lightning. But there's obviously some difficulty with it because it's expensive. So you can put little fiber optic sensors up in the blade, but then at the hub, you get all these electronic boxes, and those boxes are expensive. So these PhotonFirst is coming up with what they call photonic integrated circuits. So they're integrating the light circuit, the fiber optic circuit, with electronics. It's all one piece, which is obviously much smaller and can work faster, and it's powered by the laser and the light and everything. So it's a good combination. So the trick is, right now, if you've ever played around with fiber optic systems, they basically use what they call a fiber Bragg grating piece of optic, which is a piece of fiber optic that has little grates in it, and it bounces different frequency around. So as it gets moved around, it sends different frequencies of light back and forth. So it's sort of a complicated way of telling if something's been bending or being squeezed or moved. You can use it for temperature too. But this photonic integrated circuit is a little bit different because it's all integrated, so it can lower the price of these measurements for blade load or vibration or temperature. It's going to dramatically reduce the cost of these fiber optic systems, which I think has always been the barrier, right? It's just been a cost-driven problem.
I have used some fiber optic systems before to measure like natural frequency, I think was the main one. And on paper, they're way better, more reliable, don't conduct lightning. You can, run them next to lightning cable without worrying about noise. But in practice, we always had problems with the reliability. They were so often down, cables breaking on installation, or maintenance crews who would go into the blade for some other reason would, I don't know, crimp too much and break the cable or something. Because I think fiber optics cables are glass, right? They're not. I don't think they are plastic. I think they're glass. And if
cheap ones are.
Oh, right. And if you do too tight a bending radius, if you try and coil them up too tight, or even if you just, tread on it and kink it, then you break it. And of course, no one realizes until the crew's down and you've got to, send someone up there later on. So how do these transmit the information after they've got so the sensor is this photonics, but then are they still using glass fiber optic cables to transmit that information? Yeah. So
right. Yeah. So some of the logic is actually happening on the fiber.
Yeah.
Think of it that way.
Yeah. Okay.
It's a slick solution.
Yeah. It sounds cool. I think the I don't know, usefulness of it will be dependent on two things. One is how reliable they are, and how robust, I guess, is a better word than reliable. And two, I don't know, most wind farm operators aren't that good at dealing with a lot of data. They kind of don't necessarily want more data. So I think this will suit those kind of operators that are really keen to get in there and extract an extra, fractions of a percent of AEP. So definitely interesting to see how that can be used by the industry.
Right. And in the aerospace world, we've used fiber optics for a number of years. I remember early on that we tended to avoid it for the same reason you spoke about, Rosemary, that if a mechanic stepped on the fiber, it would tend to break it. And if you're crawling around on an airplane or crawling around in a hub of a wind turbine, it's not a lot of places to step, right? And so sometimes you can bump into it and break it relatively easily. That's going to be one of the hurdles for sure. But I think the fiber optic in general has gotten better. You're starting to see it a little more in aircraft, which means that they overcome some of those problems. But didn't you use fiber optic on some of the test turbines? It seems like where it's been used the most is on the one-off test turbine where you're trying to monitor load and monitor torsion, that you would load it with optics up front.
Yeah, more so on test turbines, but a lot of those things are trying to get it, fleet wide so that you can use it for monitoring or, predictive maintenance, structural health monitoring, all those sorts of things. People want to be able to get that data regularly to, one, know what a normal wind turbine looks like in terms of the data it sends out, and two, to be able to realize really quickly when something is changing in one of the turbines so that they can say, oh, okay, this blade might have a crack developing, or I don't know, there's a bearing fault, or some sort of misalignment of something. It's all those kinds of things. A lot of the predictive maintenance is related to rotating components.
On a test turbine, were you installing the optics after the blade was built, or were you actually putting fiber in as part of the layup of the blade?
Both. Usually, well, it depends. There's a few systems that are trying to measure the natural frequency of the blade, because there's a bunch of stuff that you can tell when the natural frequency changes. Either the mass has changed or the structural properties of the blade have changed. And those they just put on the web of the blade, and they only put them not very far down. So you can walk in, even, when it's already up on the turbine, you could walk in and install that if you wanted to. But it's kind of easier to do it in the factory, but it's kind of not. It would be if everyone was used to a big coil of fiber optics being at the root of the blade and being careful with it. But in reality, people weren't used to that, and so there were a lot of failures. It's not a problem that should exist, but it I guess you'd call it a teething problem, and we saw that a lot. So kind of for one-offs, it's probably better to do it at the end, on site. But then you've got to start working with the installation crews, and that's for me, because I was working in a factory. Then there's a whole different lot of people that you've got to fit into their workflow. So it's just like logistical things like that are the problem. It's not really something with the technology. And then there is the possibility that you could use them in other places. I know that there were some really highly instrumented blades made both by LM and probably other companies too that were trying to get a bit more clever about, knowing exactly how much the blade was flexing, for example, in operation. And that it suffered from being expensive, like you mentioned. So this would potentially be a solution for that. Not that reliable or robust was the second problem. But the biggest killer for that was that the market just wasn't that interested in it. They certainly weren't interested in experiencing any pain at all to get that extra capability. They didn't want to pay anything more. They didn't want any more downtime. They didn't want any more O&M costs associated with it. So I think, that was what has killed that. Because for at least 10 years, we've had the capability to be instrumenting blades up and knowing all sorts of things. And not just blades, but all, everything inside a turbine. You could be monitoring the vibrations, temperatures, strain, all sorts of things. But it ends up being a big distraction from, the operator's core business of making sure the turbine's running and making money from it. And kind of, monitoring this data daily, dealing with the large volumes of data and what to do with that. And, or do you have to employ a data analyst or teach somebody how to analyze the data and store it. And then, it's like 10, 15 years down the line when you actually probably see a benefit. And by then everybody can't be bothered, and, cutbacks have meant that you've stopped looking at the data. And so it's kind of, it's just one of those problems where there's heaps of potential, but nobody really has the time. It's not anybody's core responsibility. So it always just kind of gets kicked onto the next person and ignored, which is, it's a shame.
The Netherlands is putting so much money behind this because there's many other applications for fiber, especially this photonic integrated circuits, and a variety of applications, aerospace being one of them. But if you get into larger blades for offshore turbines, especially when you don't have a lot of information on the performance offshore, does it make sense to do some of your blades with some optics in them so you can monitor maybe the farm?
Yes and no. I think it just suffers from that same problem of no one can kind of, if it's not something that you need to operate the turbine, then it's, everybody's got a long to-do list, and it ends up at the bottom of it.
Well, I do think they're going to be coming into play, and we're going to see, if we start to see them in aerospace, which we are, then the transition to wind is right there, and aerospace will get some of the bugs out. I think the technology is really interesting because the data rates are really high.
Yeah.
It's fast, simple. It solves the lightning issue. It really fits into that blade technology. I think you're right. Getting acceptance in the industry is going to be the hardest part, but that's true of anything going on to blades today. So
yeah. No, I think another reason why I'm negative about it is because when I entered the industry, I'm like, oh my God, we should be doing stuff with data because, I used a lot of data in my, previous work and in my PhD. I use data mining techniques. I'm like, we could be doing so much more. The wind industry is so backwards. I don't use data. And then, you go talk to a few operators and people working on designing control systems. And, they're kind of just like, oh, yeah, that's a nice, naive thing to think that you're going to do something so clever as that. But we're all busy and we can't be bothered.
Well, everybody who's interested can check out PhotonFirst's article in Power and Energy Solutions magazine. We'll put the link in the show notes below.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
All right. So the hot news off the press from Vestas is that they've been working with a couple of organizations on a blade recycling effort that involves existing blades. So they presented a solution that renders epoxy-based turbine blades as circular without the need for any design changes. So you can take the existing blade from LM that's made with an epoxy resin system and break it down into virgin material, which is, I think, the holy grail for wind turbine blades. If you can break apart the epoxy into its components and reuse that, that's amazing. So Vestas has been working with within the CTEC initiative, and that's a partnership with Olin and Stena Recycling, and it can be used basically to any blade that's in service today. And once they mature this technology, there will be no need to redesign blades for new resin systems. And that's, I know we've talked about that on the podcast previously. So you could actually have a system where you decommission a blade, pull all the epoxy resin out of it, and make a new blade. That is amazing. Now, they're talking about getting it up to scale and all those things. It sounds like a 2-year cycle here to develop it and get into full scale. But they're saying that the chemical process was developed with Aarhus University, DTU, Olin, and other partners of the CTEC project. So it's like an industry coalition looking to recycle blades. And they're also saying, Rosemary, that it uses existing widely available chemicals to break apart these epoxies. And my first thought when I read this morning was, what are these magic chemicals that breaks apart epoxies and get them back to their virgin parts? How does that even work? Is that a thing?
Yeah, and what's the byproducts of that or the energy input? I don't know. I promised after the last segment I was going to be more positive about the next one, but it's like I get really sick of these announcements where it's like, yeah, we've got this like super cool technology. It's uses all really commonly available materials, and it's like just totally awesome, and we'll let you know when that's matured. It's like, well, if you haven't got any details at all, it's not ready yet. It's you haven't even got a timeline to it being ready. I don't know, just why announce that? I can announce that I've got the same thing for all the evidence that they have given about it, and like you say, if it's commonly available materials, it's not like epoxy resins and composite products made with epoxy resins have been tested for many chemicals, all the common ones, because you need to know, if I've got to, clean this blade and I, say I clean it with acetone, is that going to dissolve my blade or not? Yes. Like it's not, it's not like this is a brand new thing that no one ever, knew anything about what reacts with cured epoxy before. So at the one hand, they're arguing all just super mainstream, normal, just go down to what's it called? The Bauhaus. That's the like a big hardware store that they have in Denmark. So you just just go to Bauhaus and buy a bottle of this stuff and splash it on your wind turbine blade, and then it'll just turn into virgin fibers and virgin epoxy, and you just make a new blade. So on the one hand, it's like, yeah, this is just like totally easy and cheap and normal. And then on the other hand, it's this, amazing technological breakthrough. It's like you can't really argue both at the same time, can you? So
I don't think so.
Yeah.
Right. Because we've talked about epoxies on the podcast many times. And when you make you're making these changes, molecular chains, right? They're complicated molecular chains for epoxies are. And to break them in the right way where you can undo what the chemical reaction has done, right? The chemical reaction, when you mix A and B components together, produces heat, right? Because there's actually energy given off to make these bonds happen. And that's a really structured molecular reaction that's happening, and you're trying to reverse engineer that in a clean way. That can't be easy.
No, it's
there's
like
got to be a handful of chemicals
when you cure
to do that.
A thermoset resin like a epoxy, the polymers are like, strands of spaghetti. And then they not only tangle, but they also cross link. They join together, actually.
Right.
And it's like the same way, when you fry an egg, it goes from liquid to solid. I don't know if you've ever seen anyone unfry an egg, but that's kind of what they're saying, that they have come up with a way to unfry an egg using really normal materials. And I'm sure that they have, but I would, we haven't been giving any details, so you can't, weigh the pros and cons of it or assess whether it's going to ever be scalable or anything like that. But not every recycling process ends up saving energy or saving materials. It might be that you have to put in so many chemicals that are, less abundant than what goes into an epoxy resin, or you have to put in so much energy that it's not worth it, or, the process releases carbon dioxide into the atmosphere and so it's not worth it. Like, it's not, recycling sounds like, oh yeah, of course you would recycle if you could, but not every recycling process should be done. You don't always get a better environmental outcome. And I think people sometimes get a bit too obsessed with circularity. A circular economy sounds amazing, but you do still have to look at every process and if it's worth doing. And I mean, wind turbine blades in landfill aren't really doing anything very bad for the environment. So I wouldn't want to see them recycled if it meant a bunch of carbon dioxide entering the atmosphere, or even if it was a really energy intensive process, because at the moment, energy means emissions, or it means, taking green energy that could have gone to something that is currently using dirty energy. So I'll have to be negative on this one until I see some more details. And I just want people to stop making these announcements at such an early stage before they're willing to release any tiny skerrick of information that you might be able to, make an assessment by.
Well, like we've pointed out before, though, a lot of the energy used to recycle a blade is in the transportation of it. So if you could bring this chemical process to the site, the wind farm, and do it under a tent of some sort, that would be fantastic. Then you wouldn't be transporting it. That would make a lot of sense. But if you have to haul these blades back to the Netherlands or Denmark, wherever this is going to happen, that doesn't make any sense at all. Or haul them across the United States. It doesn't make any sense at that point. You're probably better off burying them locally. It's a weird trade-off. But those are some of the other engineering pieces that have to go with the analysis of the process, right?
Yeah, so we keenly await more details. Vestas, please share.
Vestas has put $11 million, almost $12 million into Modvion, the Swedish wind company, or the Swedish company that's developing the modular wind turbine towers made from wood. So Modvion announced the news a couple of days ago, saying that the Vestas capital was raised as an oversubscribed convertible note issue. So they had a lot of companies or investment firms put money into Modvion. So beyond sort of the Vestas ventures, they had some money from Almi Invest Green Tech, the European Commission's EIC fund, course corrected VC, and Symbia VC. Well, those are some pretty big names. So if you remember, Rosemary, this is the laminated wood sections that they build like a quarter of the circumference, and then you bolt these pieces together to make a tower. And Modvion is saying producing a wooden tower cuts emissions by 90% when compared to a conventional steel tower of the same height and load, which reason why they're probably getting a lot of this investment in it is because of the CO2 reduction, and that the modular nature of these sections, they can stack them on a truck, makes it easier to move around. They're doing similar things with steel, but it may be easier to do with wood. So they're saying, hey, it does save a lot of CO2 in the production of these things. Is this, and Vestas is putting some serious money, $12 million is nothing to sneeze at. So is this something that's going to see more action outside of Sweden now, or outside of sort of the Northern European countries, or is this coming to America?
I don't think so. I like the modularity of it, and transport is a legitimate problem that for onshore wind that needs a solution. So that's the main innovation that I think we need. what they're saying about 90% emissions reduction compared to steel. I mean, we're going to get green steel. That's underway now. There's, several alternative processes that you can use that will reduce emissions from steel by the same amount or more. I mean, we talked about it last week. I think we talked about electric arc furnace.
Nucor.
Yeah, and then so that is for recycling steel, but there's also several processes for making virgin steel, from iron ore, including using hydrogen. And there's a project in Sweden that's already sent their first, a year or two, maybe 2 years ago now, they sent their first shipment of steel made with green hydrogen to Volvo, I think it was. It was a car manufacturer anyway.
Oh, wow. Okay.
Should be Volvo, I guess, if it was in Sweden. And then also there's electrochemical processes like the one that Boston Metal is doing, and that one's a bit further away from, they're making steel with electricity, but not at commercial volumes, and it will be, the end of the decade before they get their first small commercial orders done, and 2030s they'll be ramping up. So, I don't know, can the wooden wind turbines come on before that? And they would want to have a lot of advantages other than just the emissions reduction, I think, to replace steel, since green steel is well and truly on the way. But the other thing is that it's so rubbery, the emissions associated with sustainable timber. And I know the Swedish forests in particular, there's a lot of controversy about how sustainable they actually are. And even if we take their word for it that this is, CO2 neutral, all of this, or you can say it's CO2 negative as well, with wood, because, there's carbon in that. And if the tower stays up for 50 years, then that carbon is not going into the atmosphere for 50 years. And a new forest is probably growing in the place where it came from and absorbing CO2 from the atmosphere. But it really matters how you manage that forest, what's happening to the soil carbon, what processing you're doing to the wood, transport, all these things really matter. And it's certainly not a sure thing that you're going to end up with a CO2 negative or neutral product at the end made out of the wood. And then aside from that, there's a finite amount of space that we can, devote to sustainable forestry, and no shortage of things that we can make from wood. So, is this really, if you think globally, is this actually reducing emissions, or is it just kind of, like apportioning less emissions to wind that are now instead going to go to, buildings, because there's not enough timber for making buildings anymore. It's kind of iffy. I don't think the sustainability part of it, that's not going to be, it's not obvious to me that there's value there in the sustainability. But the modularity, that's cool. And maybe they'll end up using their modular designs with steel towers, green steel towers, who knows?
Right. Well, it does seem like every country, every part of the world has its own solution for a tower. And every different country needs to figure out what that best solution is. In the United States, it's probably recycled steel, like Nucor is betting on here. And in Sweden, maybe it's wood. Yeah, it's totally fine, right? Find this best solution for your particular application. It depends on where you are. So this Modvion solution may work great in Sweden.
Yeah.
Good luck to
There
them.
are some really cool tower technologies around. I really like the self-erecting towers where, instead of having a crane stack sections on top of each other, you have something like that crawls up like a koala or something, crawls up and builds itself as it goes. I like those, and also there's some 3D printing stuff which sounds pretty cool. What about you? What's your favorite tower technology? Spiral welding. Yeah,
the spiral welding one, which we haven't seen a lot of, and it's been in development for a couple of years. And I think the company's based in Colorado, but they haven't heard much of them in the last 6 months. But that, I think, makes a lot of sense because it gets rid of the transportation issue, right? Because you're taking sheet steel and welding it on site and putting the towers up. So it's sort of a modular concept. We're not far from what Modvion's doing, but doing it in steel instead. So it's a cool concept. But we're going to see all kinds of ideas because of the number of wind turbines we have to build here in the States. We're going to build like 120,000 wind turbines over the next several years. we're going to have all kinds of new ideas because you need to lower the cost and make it cheaper, and complexity's got to get lower, and all kinds of different factors play into it. I'm good. That's good. I think it's good. And it's really about time we saw some pushing of advancement to simplify and lower the cost of installing wind turbines.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
Norway's wind catching system, so everybody's seen pictures of this online on LinkedIn or wherever you get your news from. They're the developer of that big wind catching floating offshore wind technology. It has a bunch of wind turbines on a kind of a steel grid. They secured a pre-project grant of, again, I'm going to say it's in Norwegian terms, it's 9.3 million kronos, right? Which is about $1 million from Enova. And if you've been following them, they've had a number of different scale-up systems they've been working on and presenting. And this is what we call what they're terming a pre-project to help mature and validate the technology. And they really get better cost estimates when they build a full-scale wind catcher. So they're going to build a smaller scaled system. Makes a lot of sense. So this is the second grant to wind catching systems that they've received from Enova. And Enova is a big supporter of the technology and the team. And they're saying, hey, we got to go. We need to make this happen for offshore installations, and which is a good idea. So a couple of things about this system, which I think hopefully going to figure out is, and Rosemary, you can point out where I've gone wrong here, is that because they have so many wind turbines on this grid, it can become maybe a little bit of a mechanical nightmare here of trying to get all this stuff working at the same time. But you pointed out it may be easier to maintain. I've been seeing some things from like on wake vortices off of standard wind turbines, horizontal axis wind turbines. I'm now curious if the Windcatcher is going to go out there, like, what does a wake vortex look off basically a wall of turbines? Is it massively big or about the same as a conventional turbine? It's interesting technology. I just don't know a lot about it.
It is interesting, and it's I get periodically. I mean, people are always asking me about this one, and I have been in some Twitter and LinkedIn arguments related to this. People are very, very sure about some aspects of the design that they're very wrong about. And I get frustrated because they have got a good idea for several reasons. There are several legitimate engineering effects that can work in their favor, and they just seem determined to, one, the benefits that they list on their website are like totally dubious, and secondly, they just seem really determined to develop it in the stupidest way as well. So, I mean, it's hard to follow exactly what their design is doing then, because they're not like installing, a bunch of prototypes where you can follow and say, oh, what does the design look like now? What does it look like now? They've mainly just got, or they've entirely just got like computer rendered images on their website. But they seem to want to design their own small turbine to then put in a grid, which I think is the first mistake that they should definitely be buying off the shelf. There's plenty of people have already, suffered all of the headaches from developing a small wind turbine. Wind catching doesn't need that headache. That's been done. And then I don't know why they won't just put like a 3x3 grid of these onshore somewhere and take some damn measurements instead of just trying to raise millions or billions to put these large megawatt size systems out at sea so that, they can go down the same path that like wave energy converters and stuff have have gone down where, your cable has failed and now you've got to wait 2 months for a weather window to fix it. And in the process, you went bankrupt. That's kind of, just seems like what's going to happen. But, it is hard to follow when you just look at their website every now and then. And I have occasionally tried to get in touch with them without any luck. But I did want to talk a bit about what the good idea is, because I keep on having arguments with it on LinkedIn with like some really, high profile in the LinkedIn world, high profile people who have really certain opinions about their design and why it won't work. So the first thing that should not be controversial, but people don't seem to understand, is when you have 4 small wind turbines in a grid, 2x2 grid, the swept area from those 4 small wind turbines, if they're stacked close together, it's going to be the same as a larger wind turbine that's in that, that's got twice the diameter. That's the same area. That's just geometry. And I did have to actually do a mathematical proof to prove that point to someone on LinkedIn who never admitted that I was right, and also was incredibly patronizing about my experience and said that I needed to told me that there were several books available on wind turbine structural design. And I thought that was quite patronizing for someone who is not an engineer, said that to me, and I have a PhD in structural design of wind turbine blades. So I was miffed. Anyway, so that's the first point, that the swept area of a wind catching system with, a whole an array of a tiny wind turbines, it's going to have the same swept area as one big wind turbine. So the amount of energy that they can capture should be roughly the same, because the efficiency a big wind turbine is not more efficient than a small one. People make that mistake as well. They assume that it's going to be more efficient, but you don't see a strong relationship there between size and efficiency. So that's the first thing. And then there's 2 effects that they have working in their favor that, to me, indicate that this is an idea worth pursuing. The first one is that, like with structural scaling laws, they're going to use less materials in their wind turbines than one large one would. So there's a thing called the square cube scaling law, where the area that a wind turbine sweeps, that's what determines the power output. That varies with the square of the blade length, but the material usage is related to the volume, which varies with the cube of the blade length. So, you increase the blade length, you get the square of the blade length in power and the cube of the blade length in mass and materials cost. So for the blades and the generators and everything like that, they should use less materials. But that said, they do have some structure, weird grid structure instead of a single tower that might be a pain. And then the second thing is when what's called a multi-rotor effect, when you put wind turbines close together, there is something that happens with the wakes, the way that the wakes interact. So you see a faster wake recovery from 4 small wind turbines close together than you do from one large wind turbine. So it should mean that you can put them closer together, and it's a little bit better. It's kind of like, imagine that this wind catching system is like a whole wind farm of small wind turbines, but they all move together. So, like a normal wind farm, when the wind changes direction, now all of a sudden you've got some wind turbines in the shadow of other ones. But the wind catching system, it's all going to yaw together. So you're never going to have anything in the shadow of it. And then the wake recovery is faster. So you can put another system closer behind. So those things are interesting, but it's very complicated. Probably like most technologies, you're going to find out that the disadvantages that you discover as you're implementing it outweigh the advantages. So I'm not saying that you should invest all your money in this company. You'll definitely make heaps of money. Not that I'm obviously ever offering investment advice, but I do think that there's a couple of real principles that are worth pursuing. But you don't see them on the wind catching website. They're not mentioning that. They're mentioning things about, using it at a higher wind speed than a normal wind turbine. And it's like, yeah, well, a normal wind turbine could do that too if the economics stacked up. I mean, anyone can just put a bigger generator on any wind turbine and have its rated wind speed be at a higher wind speed and get a better annual energy output, or you can undersize the generator and get a great capacity factor. Those are the two things that, new entrants to wind are always trying to be like, capacity factor is amazing or our AEP is amazing. But it doesn't really matter, those things in isolation. If you're not considering the finances of it, those things don't matter. And that's why, we talk about levelized cost of energy. And that's what a regular conventional wind turbine is super duper optimized to get the lowest cost of energy. And that's why they have a rated wind speed of, 12, 14, whatever meters per second and not 20 meters per second, not because they couldn't, but because the economics don't stack up. So I'd love to work with wind catching and help them because I like their idea and I hate how they're implementing it.
Well, they're still saying that one full-scale wind catching unit will produce 75 megawatts of energy, of power. So it'd be equivalent to 5 15 megawatt machines. 75 megawatts on one rack, basically, is what it is. Does that seem
it's because
mathematically possible?
Yes,
it's going to be big.
It does, but it won't. That's not going to be the design they end up with because it will be so expensive. So that they get that by saying on their website it says conventional turbines limit energy output above 11 or 12 meters per second by pitching the blades, and they do that because they, the generator is sized for the power at that wind speed, and above that there's more power, so they need to and they're saying we're not going to do that. Okay, well, that means you've got a generator that most of the time is going to be seeing much slower wind speeds. You just got a really expensive generator with a low capacity. They're just going to have very low capacity factor from this. So their rated wind speed, their turbine rating may well be 5 times a conventional wind turbine, but they'll almost never generate that. And, they're going to have a terrible cost of energy. Right. So that's not the advantage. That's got nothing to do with, their unique idea has nothing to do with that. That's just something that anybody could do. And there's other ones as well like that. I don't know why they won't communicate the actual essence of their idea.
Yeah, they haven't yet. Well, they're saying that the pilot project is going to be installed on the west coast of Norway in 2023 this year. So we should hear something about some smaller scale system by the end of this year, and then we can kind of see what this thing looks like and see what it really produces. I hope so.
I mean, the website says it delivers electricity at grid parity now, which is a bold claim from someone that hasn't installed a prototype. I mean, what's there now? They haven't even made one. How do they know how much it's going to cost? And it's annoying. I haven't really probably endeared myself to them.
Yeah, it's hard.
If my goal is that they hire me to do their technology development, and then I just criticize them all the time. But it's so frustrating because like a good idea if it's implemented badly makes everyone think that was a bad idea, and then you never go back to it, and everyone's like, oh, you have to make every wind turbine just like everyone that's gone before it because new ideas don't work. So that's why I get frustrated.
Well, you need engineers that are opposing views, because otherwise you end up with usually a not great idea at the end. Turning something into a real product requires differing of opinions to hash out what is a good solution for a product. And it seems like they're still developing that. It'll come, and there's just more to see. I'm curious. I'm really anxious to see what happens at the end of this year if they have the pilot operating and what kind of numbers it's producing. It's good for wind energy to do this now.
Yeah. And if wind catching are listening and they don't hate me because I was mean about their technology development, please invite me to see your prototype and I'll make a video on it for my YouTube channel.
All right, so our wind farm of the week is the Budweiser Wind Farm at Thunder Ranch in Oklahoma. So the Budweiser Wind Farm is sort of on I-35, right off I-35 between Wichita, Kansas and Oklahoma City, towards the northern Oklahoma border. And the site is a partnership between Enel Green Power and Anheuser Busch. And the energy from this wind farm has helped to make Anheuser Busch 100% working on renewable energy. So all the products they make are made with clean energy. Anheuser Busch purchases about 150 megawatts of power from Thunder Ranch under a PPA, and there are let me get the numbers here. There's 200. It's a 298 megawatt project and 120 turbines. So congratulations, Budweiser Wind Farm at Thunder Ranch. You are our wind farm of the week. And finally, we have some really cool names for some wind farms in America. We were looking for some because of the Thor Wind Farm over in Europe. We're trying to find those wind farms with cool names. So we're going to stick to this trend for a while. Congratulations to Budweiser Wind Farm. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.